So what we'll do is I'm recording. It'll look like I almost jumped in class. Share screen. Go here. All right. Cool. What kind of questions did you see on 8C? Yes.
Number 29.
29. All right, number 29. We have, 16.2 minus root 52. Okay, first thing you want to do when you're doing these problems is one, please don't do it on a calculator because it'll give you decimal approximates. It's not what we're looking for. So you want to start realizing I can break this down to root 4, 2. This one's not going to break down because root 2 won't break down. And this will break down to root 25 times 2. Make sense so far? Now I have perfect square, so square root of 4 is 2, so that becomes 2 root 2. This one stays as is. And this breaks down to 5 root 2. Now we have the exact same radicals, so we can add the radicals up. So the radical itself doesn't change when you add or subtract. It just acts like a variable. So we just count. So 2 and 16 added together is 18. 18 subtract 5 is 13. So I wind up with 13 root 2. Cool. What else did you see, my friends? Yeah.
31.
31. Okay. Can I move on? Okay. Let's see. 2 third root of -4 plus 5 third root of 4. Okay, so we're trying to stay away from imaginary numbers on this, but I think because we know that square root of a negative is going to give us I, that's going to work. So this is going to become third root of -4. It's third root. So I have to realize that this is the same thing as 1 times 4. And I'm going to show you why I dealt with that right now. So third roots, I can have a negative under the radical. And the reason I can have a negative under the radical is if I wanted to do the third root of -1, that's -1 times -1 times -1. So the third root of -1 is -1. Is that okay? Make sense how I said that? So that means this is going to give me this. And let me just stop there for a minute. Does everyone comprehend why that works? Okay, if not, just over on a side note, if I had the third root of -1, that's equal to -1. And the reason that works is because -1 times -1 times -1 is equal to -1. The third root, you're looking for 3 of a kinds. So negatives work when you have an odd. It doesn't give you an imaginary answer. It still stays real. Okay, so if you have third root or fifth root or seventh root, it'll work for you. Okay, now that I have that, I can then add that to 5 third root of 4. I don't know what the third root of 4 is. Yes, I could plug it into a calculator and it would give me a decimal approximate, but we want to keep an exact answer. So then we just combine. -2 added to 5 is 3. I wind up with 3 third root of 4, and it just stays like that. What else did you see? Yeah? 35. 35? Okay. Can I move on? Okay. X to the 9th y less than 1/3 plus y to the 1/9 to the 3rd. Okay. So I couldn't do my joke. I didn't do my joke of exponents earlier. Exponents. This is your biology lesson for the day. You ready? And it's going to be silly, so just go with me. And it's re-recorded, so you can go back and listen all day long. Exponents are like bunnies. Are you still with me? We've all been outside and seeing lots of bunnies come springtime, yes? So when bunnies are all next to each other, you add them up. Agreed? When exponents are on top of each other, they multiply. I'll let you attribute that to bunnies. That's your biology lesson for the day. Got it? You're allowed to laugh. Or some of you are just like, stir up. Let's go back to remote. All right, so exponents, when on top of each other, they multiply. So that's y to the first. So 9 times 1/3. 9 times 1/3 is just 3. And then y to the 1/3 power. Is that okay so far? I'm going to distribute this in. So that's to the first here. Plus x raised to the third. 3 times 1/9 is 3/9. 3/9. 3/9 is 1/3. How many of these exact same terms do I have? 2 of them, because there's a 1 in front. So I have 2 x third root y to the 1/3. Make sense? Anything else off the homework you'd like to take a look at? Yeah.
For that one, if we wrote 2x cubed and then the cube root of y, would that have also been?
Oh, you like this? Yeah, I would take that too, totally. If it was multiple choice, I would probably have this as the answer. I wouldn't put both and act like, there's a more correct answer. I probably wouldn't have choose all that are correct. I think that's kind of mean. But I have to warn you, there is an online quiz that after today you should be able to take. Okay, it'll be due, I forget. I think it's Sunday, or I can't remember. It's online. Mr. Padovic wrote it. I proofread it. I think it's good. I would highly encourage you to make sure you have notes out when you do it, because there are some that are all that apply. Okay, not exactly like that one, but just got to warn you. Okay, so that's coming up. And then Thursday, Friday of next week, so it'll be Thursday for y'all, Thursday, Friday of next week, we will have an in-class quiz. Okay, but we'll have one that'll be on Schoology that I think it's open now, and I'd like it done by, I think, Sunday. I think that's where I put, but I'll have to double check. Any other questions off of the homework? You okay about it? All right. So I am going to give you notes. This packet of notes is good for today, and it's also good for when we have class again on Thursday. Okay? So please bring this back. And also there is a stack of white paper up on the very front desk. If you ever need scratch paper, just go grab one. You don't have to return it. If you ever need a sheet of paper, just come grab something out of the pack pile. Every now and then I might have something on one side that's not important. It might be like an old test that you can sell online. I get half your profits, okay? Yeah, booty. Everyone get notes? I didn't forget anybody? Okay, ready? Now, friends, I know this chapter 8 is by far the toughest chapter of the entire school year. Okay, and I'm not saying that to scare you or be mean. I don't want you to panic if you are in the B range after we get done with our testing, our quizzes for this chapter. Don't panic. The 4 chapters after this are far easier, and everyone's grade will come up. Okay? I'm just saying that. I don't want to be mean. I just know that this chapter has a lot of meat and potatoes to it. It's a good chapter, but it is a little bit tougher. Please stop me during any lesson. And if you ever want to come see me to get extra help, my office is right next door. Come before school. After school, I kind of slip out of here a little quicker. though, if I slip out of here, if I'm like gonna be leaving, if you come after school, I will stay. Don't worry, you're not hurting my feelings. I just need you to know that I am the game manager for our gyms for our basketball games. So when we have basketball games, I won't be there 8th period, next door in 8th period. I'll be over in our gyms getting things set up. Okay. I will tell you when I have games, just so you know, I'm also off 2nd period. If you're off that period, please feel free to come by next door. If I'm not there, y'all have my number. Send me a text saying, hey, I wanted to come get help. Send me a text. And I'm also off 4th period. So you're welcome to come next door. I'm no longer off 7th period. I have business calc then, which is a good class. So here's the really beautiful, wonderful thing. Everyone passed the polynomial capstone, okay, which is great. There are 2 more capstones that we'll have to take this semester. We probably won't do it on Schoology like we did unless we go back to full remote learning, which I really hope we don't. So you see someone coughing and hacking, you make sure they go home and you walk the other way. Don't walk through their cough and sniffles. Okay. We'll actually take it on something, a thing. We'll take it on one of the Chromebooks, which we use a program called Illuminate, which you haven't used yet, but it's pretty user friendly. So, but those are coming up. They will be a while away. The next 2 capstones, one of them is on logarithms. We haven't done the logarithm chapter yet, so that'll be probably in 4th quarter. And we have rational functions, which I think we will do before spring break. Okay. My friends, here's the greatest thing in the world, though. The polynomial capstone that everybody passed is the toughest of the capstones. Okay. In fact, because you all are all really good test takers, I could probably give you the next 2 capstones without even teaching it. Because you're good test takers, I bet you could all pass it with a 6 or better. Okay, without even knowing the content. Okay, because you all know how to take tests. You can go through your process elimination, stuff like that. So I'm putting that out there. It's nothing that you need to panic with. I told you I'd get you all through the first one, which you did. I applaud you. I think I had one student whose computer froze up and then had to retake it. Not because they did anything wrong, it's because there was a computer error, whether it was on school's part or the student's part or both. I don't care, it doesn't matter. But that student passed, which is great. Okay, this is 8D, exponents, radicals, rational exponents, and mental math number sense. Rewrite expressions with prime bases. So remember, a prime number is a number that 1 in itself can go into. Yes, there's always a math debate. Is 1 a prime number? Is it yes or no? Some people say yes, some people say no. I say they're both right because I think it's a valid argument either way. But then that 2 and 3 are both prime numbers, 5 is a prime number, 7 is a prime number, so on and so forth. And then we're going to be trying to evaluate without using a calculator, which basically means I don't want you to do square root of 4 and tell me it's like 1.417327 or whatever it comes out to. Okay, so we want to keep it as an exact answer. Okay, let's move on. All right, so these are, if I have 1, 2, 3 through 9, actually it goes a little further, it goes through 10. If I square any of those numbers, I get 1, 4, 9, 16, 25, 36, 49, 64. If I cube it, so I take a number times itself, I get 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1,000. The next one are if I do a number to the 4th power, I get 1, 16, 81, 256, 625, 1296, and then you have 10,000. Notice I have some blanks in there. There's blanks in there because basically we want you to know those as kind of go-tos, but you don't use them every day. So I'd say the perfect squares, because you've dealt with that for multiple math classes. Perfect cubes, you don't always have. You might have like 1, 8, and 27, and you're good. Perfect fourths, it sometimes just becomes harder to remember because again, I'm just putting this out you've seen it once, you haven't been doing this type of math since 6th or 7th grade. Okay, so I just want you to know these are available, but don't panic if you don't have them memorized. I don't think you need to go make flashcards and have it down, though it would be a great way to learn them. Is it going to help you in the grand scheme of all math out there? I doubt it. Okay, so I'm just putting it up that it does exist. Yes, these numbers here and here and here do exist, and here and here exist, so on and so forth. You can go 2, 3, 4, 5. There could be to the 6th, to the 7th, to the 8th, to the 9th. But I'm going to show you a way that you can do them that you'll start feeling comfortable, okay, without having them necessarily memorized. Okay, so we want to rewrite each expression in prime bases. So 225. So I like doing these starting out kind of as maybe a factor tree. Okay, yes, there's all these kind of fun rules that perhaps you learned in earlier math classes and perhaps you didn't. You're like, okay, I know that 2 always goes into a number if it's even. I know 3 goes into a number if the last 2 digits are divisible by 3. I know 4 goes into a number if this iteration takes place. I know 5 goes into a number if the number ends with a 5 or a 0. I know 6 works, and there's a whole rule for 6s. 7s work, whole rule. We're not worried about the rules. We're worried about, can we just start breaking numbers down? So a lot of people might say, well, I know that 5 times 45 is the same thing as 225. Does my math work? I hope so. So I know that 5 is a prime number. Okay, so we're okay there. But I know that I could break 45 down to 5 times 9. So now I have these 2 prime numbers, both being 5. And I know that 9 can break down to 3 and 3. So if I multiply 5, 5, 3, and 3 in any order together, I'll get 225. Seem okay? Let's do the same thing with 112. Okay, so I think my smallest prime number that would work would probably be 2. And 2 times, was that 56? Would be the same. I know 2 is a prime number, so I'm going to leave it as is. But then I know that 56 is going to break down to 2 times, is that 28? I know that 28 breaks down to 2 times 7. Nope, oh, shoot, 14. I went ahead in my head. And I know 14 breaks down to 2 and 7. So if I multiply 2, 2, 2, 2, and 7 together, I would get 112. 108, same idea. That's 2 and 54. I know 54 breaks down to 3 and 3 and 18. Okay. I know 18 breaks down to 3 and 6. 6 breaks down to 2 and 3. So 2, 3, 3, 2, 3 multiplied together gives me 108. 60 breaks down to 2 and 30. 30 breaks down to 2 and 15. 15 breaks down to 3 and 5. And notice I started skipping over stuff because I didn't think I had to get over into the 4th grade math of breaking numbers down. So quick way to do it is if you have a calculator, take a number, divide by 2. Then divide by 2, take that same number, divide by 3. Oh, 3 works. So 3 times something is going to give me the next number, and so on and so forth. So you want to get it down to its prime components. Okay. Now they want to have us list these with the appropriate exponents. Okay, so this is the same thing as 5 squared times 3 squared. This one is 1, 2, 3, 4. So this is 2 to the 4th times 7. This is 2 to the 2nd. Oops. I messed up on this one, didn't I? 2, 30. That should be a 5. Is that right?
Yeah. 2
squared times 3 times 5. And then this one is 2 squared, 3 to the 3rd. Okay? And it's going to help you having the exponents, but it could also help you having them written out. Sometimes the exponents work better. Sometimes having it all written out works better. Sometimes your mind will work one way or the other. It doesn't mean your mind is broken. It just works one way or the other. That's all I have there. Am I doing okay so far? All right, let's break up root 80. Okay, now some people might see a perfect square in there. Some people might realize that 80 is the same thing as 16 times 5. Sometimes. You don't always see it, but I'm going to show you how to do it if you don't see it right away. Square root of 16 is 4, so this comes out to 4 root 5. But let's say you don't recognize that 16 goes into 80. That's possible. So that means that 2 times 40, 40 is 2 times 20, 20 is 2 times 10, 10 is 2 times 5. Okay? So this right here, 2 times 2 is 4 times 2 is 8 times 2 is 16, gives me my 16. So when you start looking for this, you realize this makes the 16 and the square root of 16 is equal to 4. And then I'm left with the root 5 with it. Same thing with this problem. It's sometimes hard to recognize that there is a perfect cube that is an 80. Okay, now how I would say as a mathematician you would do it, you would probably do it as 8 times 10 because 2 times 2 times 2 is 8. So 8 is a perfect cube. So this third root of 8 is 2, and then I have third root of 10. But let's say you don't see it that way right away. Well, let's break 80 down the same way we had done right there. And that's third root. So the third root means I'm looking for 3 of a kinds. So that's a perfect cube. Then you have third root. What do you have left? 10. So they match up. So it's your choice how you want to do it. The purple way is how the mathematicians of the world want you to see it. But not everyone is a mathematician. People are math-minded, but not always mathematicians. Which way is the right way to do it? The way that you do it that allows you to get the right answer. Okay? And I really get fed up. There's a lot of teachers that are like, no, they have to see it this way. If they don't see it this way, that's wrong. But they get the right answer if they do it their way. Oh, no, but they're doing it wrong. But they got the right answer. No, but they're doing it wrong. I don't know what to do. I often argue this type of thought process a lot of times with other math teachers. I don't do it as much here. There's been other schools where I had some prima donnas I taught with. Here, I feel really comfortable with my teams. We realize everyone's going to think a little differently. Not, oh, you have to think as a mathematician. You're like, okay, there goes me being an engineer. All right, so let's see. We want to evaluate these without using a calculator. Well, I think a lot of you might look at this saying, hey, I know that 9 times 9 is 81. Okay. But if you get to that step, you'd probably be able to get down to this step and realize that 3 times 3 times 3 times 3 is also 81. So the fourth root of 81 would come out to an answer of just 3. Where did the radical sign go? I used it. I took the fourth root of 81 to get 3. This to the 1/3 power. Well, the 1/3 power, I'm going to keep that negative. That's just going to come out. This is the same thing as saying the third root of 125. And we'd like you to start realizing that 125 breaks down to 5 times 5 times 5. Your first step is 5 times 25. 25 is 5 times 5. So the third root, and this negative has to come along for the ride, the third root of 125 is going to be just 5. So we get this negative. That negative, because it was outside, carried down. It didn't get impacted by the radical sign. It comes down to just say, hey, we want the opposite value. Do we feel comfortable with what I've done so far? Now I actually get to read your body language versus guessing what's behind a black screen because your monitor is not on. So I actually become a little bit better teacher this way. Though I don't think if I was home as a student, I don't think I'd have my video on either. I don't want someone to know who's teaching the class that I actually walked away and left. You want to know how I know the students left? I got done with the class. Johnny, you're still on. Johnny? Johnny, if you're talking, I can't hear you because your microphone's muted. Johnny left. Johnny's making a sandwich. Oh, this is kind of fun. There was definitely things that made me giggle a little bit as a teacher. The one, it didn't happen here because we would just give you a quiz just to do online. But there was times I had in Algebra 1, get into the Zoom meeting. Hey, everybody. Everyone turn your camera on. Everyone's camera's on. Okay. All right, I want you to take this test. Billy, your camera turned off. Oh, it doesn't work anymore. It was just working. Well, it's broken now. Really? Or do you not want me to see that you're taking your cell phone and using photo math on my problems? I don't know. Just got silly. But we got through. All right. So I have 36 raised to the negative 3/2 power. So when we have a negative exponent, that means that our number wants to switch from being a numerator to a denominator, or being a denominator and becoming a numerator. So moving from top to bottom of a fraction or bottom to top. So I'm going to rewrite this still using my exponent. So you have that. And then you have to kind of recognize my denominator here tells me what radical we're dealing with. So this is going to be the same thing as the square root. I'm going to put a 2 there. Now square roots, we know we don't have to put a 2 there, right? I'm just showing you where it shows up. Now, when you're doing these kind of problems without a calculator, sometimes it's easier to take the square root and then cube it. Sometimes it's easier to cube it and then take the square root. I can't tell you which ones are better. This one, I would say take the square root of 36 first. Square root of 36 we know is what? 6. So this is going to become 1 over 6 to the third. 6 to the third is 216. So that becomes 1 over 216. Ooh, number 10. I think that's supposed to be squared. Would you buy that? I don't know what happened to my font. I think it's supposed to be squared, so we'll act like it's squared, okay? Okay, so the third root of negative 64. First off, can I have the third root of a negative? Yeah, it exists as a real number, agreed? So anyone know what number times what number times what number gives me 64? It's the exact same number. 4, good. So this is going to become negative 4 squared. Notice I kept the negative 4 grouped. The reason I kept it grouped is because I wanted the third root of a negative, and then I want to square that. 4 squared, or negative 4 squared, is going to give me positive 16. And we're done. May I move on? Well, what time we got here? This is third period, 11 o'clock. Cool, got time. Okay, evaluate without using the calculator. First, it's to a negative exponent, so it's going to become this. Third squared. Okay. Hey, why did the 8 stay negative when I moved it down? Anyone know? It's grouped. And the negative with the number doesn't switch signs. If I have negative 4, that's not the same as 1 over 4. The negative exponent is what moves it. The negative number does not move it down. So this negative number here has to stay negative as we move it down. And notice I changed it to the third root of negative 8 squared. So I modified that. So the third root of negative 8 is negative 2. And negative 2 squared, quantity squared, is 1/4. This is the third root of 1,000. Third root of 1,000 is just 10 because 10 times 10 times 10 is 1,000. Fourth root of 32. I know my base has got to be 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 times 2 is 8 times 2, or 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. How many of a kind am I looking for? 4. I'm looking for 4 of a kind. I'm looking for 4 of a kind. So if I were to multiply those together, it does come out to 16. The 4th root of 16 is 2. But I still have left inside a 4th root of 2. And notice I still have the 4th root in there. Don't lose the little superscript. It'll exist. Then we have number 14. Okay, now let's pretend I'm saying don't use a calculator. Well, I'm not going to expect you to go double-digit multiplication times double-digit multiplication on your own. Okay, see if you can follow what I'm going to do here. Let's make a little more room. Let's extend it. All right, so this one, I'm kind of bringing all down here. Can I break 27 down? Does it break down to 3 times 9? 27 breaks down to 3 times 9, then it's the same thing as 3 times 3 times 3. Agreed? So the first 27 is going to become 3 times 3 times 3. That's okay or that. That's the same thing. So that's going to be another 3 times 3 times 3. Notice I put it all under one radical because we're multiplying it. They're the same radical. We can put them all under the same sign. Now, here's basically the algebra 1 thing. I have x, and then I have those. 2, 3, 4, 5, 6. Now, this is kind of a generic way of doing it, but it allows you to see it. There might be some mathematicians or math teachers have in the future that might look at you doing this going, why are you doing it this way? Because you might see it this way, and that's okay. Hold your ground. Your teacher says that's not good enough. Let me know, and I'll go talk to that teacher, including your college professors. Got it? Y to the third breaks down to y, y, y. Y to the fifth is y, 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 y. Okay? How many of a kind am I looking for? 5 of a kind. 5 of a kind gives me a perfect fifth. So it gives me a 3 outside. I still have a 3 left inside. Agreed? I'm looking for 5 of a kind on the x's. 1, 2, 3, 4, 5. I have an x outside. How many x's are left inside? 2. And then go to the y's. Looking for 5 of kinds. 1, 2, 3, 4, 5. So I have a y outside. Why don't I have 5 y's outside? Because the 5th root of y to the 5th is just y. Now I have left behind the 5th root of a single 3, x squared, I have 2 of those, y to the 3rd. So this entire thing is your answer. That big old radical right there looks to some teachers that you don't know what you're doing. You know what it looks like to me? You got a thought process. That's okay. As you work with these a little bit more, you'll become a little bit faster, but this is totally a legitimate way of doing it. May I move on? Good to go. All right, evaluate without using a calculator. So realize I have a 3 and a 2 that are going to be outside. I'll just leave those as 3 and 2 for right now. Okay, yes, I could multiply them together. I will at the end. I'm going to put everything underneath the same radical sign. I want the 3rd root, but they're both 3rd roots. So 10 is the same thing as 10 times, or 100 is the same thing as 10 times 10, plus times that last one. Do you agree with the math so far? How many x's should I write below? 3. Now I'm going to do it the mathematician way. I want 3 of a kinds. So I have 3 x's underneath there. So I have x to the 3rd. Agreed? Is that the same thing as x, x, x? Okay. How many y's do I have under there? 6. Does 3 go into 6? It does. So I'm going to leave this as y to the 6th. Do you agree? Okay, yes, I could write out y, and look for 3 of a kinds. Okay, so now I'm looking for, because of this 3, I'm looking for 3 of a kinds. So it means I have the 3 and the 2 already sitting out there. Now a 10 is going to join them. And x is going to join them. And a y squared. And why is it y squared and not just y? Because 3 goes into 6 twice. And if 3 goes into 6 twice, that means y to the 6 is the perfect cube. Y to the 6 is the same thing as y, or it's y to the third, y to the third, y to the second, y to the second, y to the second. But if you're looking for 3 of a kinds, that's going to work. Let's take care of the math. 3 times 2 is 6. 6 times 10 is 60. So I get 60xy squared. And the problem's done. And there's no more radical because we had perfect cubes in there. Woo! Woo! Good stuff. How many of the kinds are we looking for on this next problem when we put it together? 3 of the kinds. Okay. Now, I know my perfect cubes because we started working with them. I know 1 is a perfect cube. That's great. I know 8's a perfect cube. Agreed? Because 2 times 2 times 2. I know 27 is a perfect cube because that's 3 times 3 times 3. And then I start forgetting, but I think 64 is the next one because that's 4 times 4 times 4. 125 is 5 times 5 times 5. 216 is 6 times 6 times 6. And I'm just showing off because I've done this way too many times in my lifetime. So things like that have stuck. Okay, so I'm looking for 3 of a kinds. Okay. We said 8's a perfect cube, agreed? So let's start there. Let's break 54 up using 8. Is 54 the same thing as 8 times 7? Is 8 times 7 54? Are we sure? Oh, it's 56? Oh, okay. So I'm going to go backwards. That's not going to work.
27 times 2.
Oh, yeah. 27 times what?
2.
Oh, somebody saw that. Somebody saw that as 27 times 2. Good job. Okay. You agree so far? 27 is the same thing as 3 times 3 times 3, yes? Okay. All right. We have this negative, and I know I can have a third root of a negative number, yes? Ooh, 162. 162. Let's see. 4 times 4 times 4 is 64. 64 times, is that going to work? No. How can I break up 162? I don't see it right off the top of my head. So if I don't see it off the top of my head, let's do this. 2 goes into 62 81 times. 3 goes in there 27 times. Hey, that 27 means something. So 27 times 2 times 3. And we're going to make the 27 our negative to abide by that negative. Okay. Third root of 27. 3. Third root of negative 27. Negative 3. Do I have any more 3 of a kinds in here? I have a 2, and a 3. I don't. 2 times 2 is 4. 4 times 3 is 12. Multiply outside, negative 9. Third root of 12. Problem's done. Ooh, this is goofy. Oh, I think I'm almost done. Or am I done? Number 16. Got one more thing. Ready? Can I move on? Okay, simplify the bases. Okay, so first thing, I have the third root of 16 and I have the square root of 2. They're not the same radical, so I can't just reduce it. If I had third root of 16 over third root of 2, I could reduce it because they'd be the same radical. But these are not the same radical in this case. So I'm going to realize that I'm going to take third root of 16, and I'm going to break that down to third root of 8 times 2. Third root of 8 is 2, so that's going to give me 2 third root of 2 over square root 2. So that's my first step. Okay, next step, I want to take third root of 2 and I want to make it an exponent. So third root of 2 is 2 to the 1/3 power over 2 to the 1/2 power. Oh, boy. So I'm going to modify this. I might have jumped ship on that real too quick. So that's going to give me 2 4th root of 3, or 4/3, 2 to the 1/2. Tug of war means I'm going to subtract my exponents. When I subtract my exponents, let's do my crisscross way. 8 minus 3 over 6 is 5 over 6. So my answer comes out to 2 to the 5 over 6 power, and we're all done. Ooh, that was, ooh. So I made an error. I did not need to show this step. I probably should have jumped right to this step. This is square root, this is square root, yes? So that's the same thing as saying square root of 18, which is the same thing as 18 to the 1/2. Okay. 2 to the 1/2 is the same thing as square root of 2. Oh. Ooh, okay. They're both to the 1/2 power. 9 goes into 18, or 2 goes into 18 9 times. So 9 to the 1/2 power. The 1/2 power is the same thing as square root. Square root of 9 is 3. Yowzers. Friends, I think we've covered enough for you. I will record the last two real quick as you're leaving, but let's have us do 8D. Will be due next time we have class. 8D will be due next time we have class, okay? And I'm just going to cover these last two because I'm still recording. Friends, have a great day. Take care of one another. Yes, sir.
So I'm gonna be going so Thursday to Tuesday. So
Okay.
Your school's pretty easy to follow, so I'll be able to probably keep.
And I'll have the video up too for you.
Yeah, and I'll just send you 8D. I'll do it tonight and then text you a picture before tonight.
Or you can just show me next time we have class. Either way,
Okay.
it's totally fine.
Yeah, and then I'll try to watch the videos if I have internet, but I'll make sure to stay on top of everything, get everything done.
Perfect. Perfect. Thanks for letting me know.
Yes, sir. You have a good one.
Yeah, buddy. You too. Okay.